Now, see, suppose let's say you have a very heavy object. Let's say you have a big stone. Now, moving that stone is very hard, right? Obviously. See, there are a lot of things which comes into play. One, the weight of the stone, obviously. Then, there might be a lot of friction on the ground. Even that also plays an important part. Okay. Now, let's assume that we just have a stone, let's say on a smooth surface. Okay, very heavy stone on a smooth surface. See, even then, pushing the stone is very hard, correct? Because of what? Because of the weight, or we can say because of the mass, correct? More the mass, obviously the weight will be more. So, movement of the object is quite hard. So, let's generalize that if you have a very heavy object, then movement of those objects is very hard, correct? So, this property, that is where the body appears to be only in state of rest or of uniform motion. So, this the opposing of any change, this is basically inertia, right? Newton's first law of motion, right? So, what we can say is greater the mass, greater the inertia, right? So, this is for any translatory motion or rectilinear motion. Now, in analogy to this, we also have body which is rotating about an axis. Even this also has a property to oppose the change which is causing it. Okay, this property is what we call as moment of inertia or rotational inertia. Okay, so this plays a very important part. Like practically, we have a lot of examples for this moment of inertia. Okay, like the wheels what we have for almost all the vehicles. Let it be from a bicycle to even a big trucks also. The wheels are designed in such a way that the moment of inertia has to be very high. So let me explain what is moment of inertia. Okay, see, moment of inertia, how we define it is the moment of inertia of a particle about an axis of rotation is equal to the product of mass of the particle and the square of the distance from the axis of rotation. Okay, I'll repeat this again. The moment of inertia of a particle about an axis of rotation is equal to the product of mass of the particle and square of the distance from the axis of rotation. Okay, so this is basically moment of inertia. Okay, now conceptually speaking, what moment of inertia is? It is very similar to what we have for normal inertia. Okay, so a body is rotating. Okay, so it opposes the change. That's basically rotational inertia. Okay, so mathematically speaking, like the definition says, we have I, which is moment of inertia. I is equal to mr square, where m is the mass of the particle and r is the distance of the particle from the axis of rotation. Okay, now see, look at the figure. We have some irregular object. So here we have different masses, correct? m1, m2, m3 like this, and the distance from the axis of rotation is r1, r2, r3 like this, correct? So each particle has its own moment of inertia, correct? So we can say, let's say if the first particle has m1 r1 square, then m2 r2 square. So what will be the moment of inertia of the whole body? It will be the sum of moment of inertia of all the particles, correct? So we have I is equal to m1 r1 square plus m2 r2 square. So like that, so on till mn rn square, right? Or we can also write this in terms of sigma notation. We get I is equal to sigma mi ri square. I is equal to 1 to n. Okay, so this is basically the mathematical formula for the moment of inertia. Okay, now see, you guys understood the mathematical formula of inertia, right? And I told you in the video that there are a lot of practical examples, especially the wheels of vehicles. So what is the physical significance of moment of inertia then? So that's what you will see in the next video.